Hello everyone. Good afternoon, and thank you for joining us. So day two, so the second in the series of our RedR webinars. So the second in the series of our RedR webinars, which are running until the end of the week and which are part of our main fundraising event of the year, RedR, in which we're celebrating our work, we're engaging with our supporters, and we're also raising much needed funds to help us continue our work. All our RedR webinars are free to attend, but we hope that you will be making a donation in return, however small or big. The easiest way to donate is through our Just Giving page. You can see the details on the slide, and you can also find the link in the chat box. And back to our session today. So today, most of you probably know already, but for those of you who don't, RedR UK started off as a register of engineers for disaster relief. These days we are much more than that, but we still have strong connections with the engineering sector. And today's session will be looking at the role of the engineers in the humanitarian aid sector. Our host for today is Noor Kuchai, who recently joined RedR UK as a technical program coordinator. His CV is very impressive. He worked as a humanitarian engineer with UNHCR in Afghanistan. He has a PhD in building physics and humanitarian engineering, and the list goes on and on. But rather than me going on about it, I will let Noor take over. But before I go, just to add, there will be a Q&A session at the end. So if you have any questions for Noor, you can either post them in the chat box or ask them at the end of the session. So hope you enjoyed the session, and Noor, the stage is all yours now.
Thank you very much, Neetha. Thank you very much for the great words. Hello, everyone. I'm gonna share my screen with you now. Okay, where is it? Here, full screen. Never works on the first. Share audio, share. Okay, I have to make this full screen. All right, so can everyone see this? Can you just? Okay, great. And you can hear me clearly, yeah? Right. So I'll be presenting today about the role of engineers, the role that they can play in the humanitarian sector, and which is very vital and important. How do I? Next slide. Okay, there you go. Well, I could not list every engineer, every type of engineering that you might be involved or you can guess of, but I have just added a few engineers, titles of engineers that there's those who can contribute towards the very important work in the humanitarian sector. Engineers play a vital role in providing both long and short-term support for the disaster relief, and I don't call them anymore natural disaster and conflict disaster. I call them disasters because most of them are as a consequence of human interventions. So structural engineers, they can assess the damage and they can give a go or no go to buildings that can be used for communal purposes. Also, they can be involved in design of structural elements of the building. Civil engineers can do the community access roads, hospitals, water points, pipe schemes, and many civil related projects, which I was doing mostly. Electrical engineers can play a vital role in providing electricity and supplies, mechanical engineers as well, and communication. I mean, communication engineers could play a very vital role in SATCOM and communications. But the problem is in the universities, most of the time students are not really told that they can play a very vital role. And the good thing with the humanitarian sector is that your role will be very diverse. you will not be doing just your pure hardcore engineering, but you will be using your engineering skills to solve real-time problems of the very affected and needy community who are struck by disasters. Because humanitarian sector is full of problems, so it brings a lot of opportunities for engineers, and engineers are very good in problem solving by default. That's how they are trying to solve problems. So yes, that why engineering, humanitarian sector is very interesting in terms of problem solving for engineers. The first slide is about me. Twice displaced by war. I grew up in a refugee. The left photo on the bottom, that is the classroom. The person in red circle is me, with my classmates, with no roof or classroom, anything. Then I studied engineering in Afghanistan in Eastern Region, Nangarhar province. Then joined UNHCR as a shelter officer, later promoted to program associate. Then I did my master's in construction management in UK, Cardiff, and recently submitted my thesis at the University of Bath, mainly related to building physics and humanitarian engineering. The title of my thesis was the role of computational tools in designing healthy housing for the displaced. My role was very diverse with UNHCR. So I was a member of the technical unit, implementing partner selection committee, shelter, program, and protection, basically for all types of reintegration projects. I've just added a few photos. Recently, I won the doctoral recognition award in Bath. So you can basically see all 3 stages of my life in this one slide. Next one. How does it go? Okay, so I started working as a shelter officer. I was providing houses for the displaced, internally displaced, and those who were returning back from Iran and Pakistan to Eastern Region, 4 provinces, Nangarhar, Jalalabad, Kunar, and Laghman provinces. We were providing 2-room semi-permanent shelters. Semi-permanent, they are called because sometimes they would want to return back. The affected families would want to return back to their place of origin. So the roof, the windows, and those were dismantleable, and the walls and foundations were more made of local materials, so they would be left there locally without having any environmental impact, which was very good. Besides the project, the shelter project, hygiene awareness was a massive chunk of the project that was implemented in the shelter project. So how would it work? That the shelters designs, the technical drawings would be provided by the UNHCR, and then the houses were being constructed by the beneficiaries themselves, and UNHCR would provide technical guidance and supervision. So this way they would have a house, and also they would be upskilled. They will have the skills of making a non-engineered building, basically. These sort of structures do not require a lot of engineering, but they do require precision when you are doing the layout and drawing the maps and plans for it. So I was also involved in tendering and RFPs, requests for proposals, and preparing bills of quantities. Like I said, I was involved in the procurement committee, selecting the implementing partners for those locations where UNHCR could not go. So we would have implementing partners who would have local staff who could easily access remote locations and remote villages. So what you need to know is that when you're working with the aid agencies, you really need to have this rapid implementation strategy. Things happen rapidly, and you need to provide rapid response, quick solutions, and immediate action needed, especially in the first 72 hours. And the main focus of the aid agencies are mostly localization and empowerment. So try to use the local resources as much as possible, and try to enhance the skills and strengthen the local skills that is available. Then after shelter associate, after that position, I started working as program associate, and my responsibilities became more diverse. And in the photos you can see is the first computer center for female in Sarasha village of Nangarhar province. The whole computer center was run by solar powers, entirely powered by renewable energy and only for female. This is one of the examples. I was responsible for implementing several quick impact projects or cash for work projects that included several reintegration projects, protection wall, pipe schemes, water points, micro hydropower, school buildings, community centers, and women empowerment, GBV, and human rights projects. Now, why were we doing infrastructure projects in the villages is because we were using the infrastructure projects as gateways to enter the villages, and then we could implement sensitive projects. You just can't go to a village in a remote location that, oh yeah, here we are, we're going to implement a literacy project or a human rights project or women rights project. So what you would do, you would go with a package of construction project or infrastructure project. You say, we are going to do this reintegration, irrigation project, but it has another component of women empowerment, and we are going to provide vocational training for women. So this will upskill the residents and the affected population, and it will bring them chances of livelihood opportunities. Some of the projects, for example, on the top left is a solar panel. The reason for that was in this village during the day, women could not fetch water. So they would go evening and it was dark and not risky for them to go out. So solar panels would charge the battery, and the battery will turn on the light at night. So it will provide access to water. The second example is a water point. This is how dangerous it was before, and then you can see the photo on left, which is covered and its access is safe. It's going to safely be accessed. School projects, the one I am standing with the hat, you can probably see, is the one then completed on the left is for women and female students. Micro hydropower projects and then vocational trainings, as I was saying, was always going along with the construction projects. And I will tell you why am I showing you the reasons for implementing these projects. I can't go next, yeah. Again, micro hydropower projects, water points, and this one is a water tower, which was completely powered by solar panels. So during the day, the solar water pump will take the water in the reservoir, and throughout the day, residents will have water. The reason for doing this, the government had allocated a land for the returnees who are coming back, but this area had no water, and people who are allocated land, they would not live there because of lack of water. So UNHCR would construct these water reservoirs as a pull factor to attract more returnees and refugees to return back to Afghanistan, and then have access to water, schools and livelihood opportunities. So as an engineer, sometimes there's a river, and the society, the village is heavily depending on agricultural crops. So there's no water. So what you will do, you will construct, do a feasibility study, construct an irrigation, mini irrigation dam, and then that water will be, the elevation of water will be increased, and then the whole village will have water. This is sometimes done as part of the coexistence projects. For example, there is a village and 50,000 people are living, another 30,000 people are displaced from another location, and they are now living in the same location. So the resources is already stretched, and it's even more stretched because of the new displacement. So as you increase the amount of water, you increase job opportunities, and you are trying to bring community coexistence in the village. This is one of the examples. As you can see, the village on the left has water because it is submerged. It's under the water level, but the other part is dry. So what you will do, you will elevate the water level, and then water will reach to the dry part. So enabling more agriculture, creating more job opportunities, and ensuring sustainable reintegration, sustainable voluntary return, and also fighting displacement. So people won't be displaced because of lack of job opportunities or resources. So why would you choose the aid agencies? Why infrastructure? Well, with the aid agencies, when you are working, yes, you are getting a salary, but you're also bringing smile to the people who have already suffered, and they have suffered a lot. They have lost everything, and you can bring that hope. You can bring that smile in their faces with your salary. You can work in a construction company, you can work for someone, and that's your choice. But if you work in the humanitarian agency, it is very satisfying. You will somehow, or you will directly or indirectly ensure sustainable reintegration of the communities. You will fight the further displacement and movement of populations around the world or within the countries. As predicted by IDMC, by 2050, there will be 1 billion people displaced around the world. It's because of the climate emergency, climate change, and also the conflicts. And there are many other parameters that they have taken into account. So we all can play a part in trying to reduce displacement, trying to help people, and that engineers can play a vital role in the engineering sector. So yes, you can use your skills as gateway for sensitive projects as well. You can use your skills for helping the needy people the ways that you might have never thought. That your discipline you might think is not related to humanitarian sector, but there is a lot of opportunities for every discipline in the humanitarian sector. So now I'm sorry, I'm talking a bit quick because there's so much to share and I'm trying to cover, and please do ask. And if you wanted more information, please do get in touch. So after I did my master's, I started doing my PhD in the UK and the University of Bath. The title of my PhD was The Role of Computational Tools. So I basically investigated the role that computation tools can play in designing healthy housing for the displaced. My research was part of a bigger research initiative by the University of Bath, and you can call it a multidisciplinary, transdisciplinary, or interdisciplinary team, probably the most interdisciplinary team I had ever worked. But we had building physicists, architects, environmental designers, sustainable materials experts, anthropologists, civil engineers, and mathematicians. But also from all over the disciplines, we came together, try to solve this, the problem of the housing for the displaced in the humanitarian sector. The project was divided into 5 packages, and the reason for dividing it was to manage the project effectively and complete it on a timely manner. The principal investigator was Professor David Coley. Some of you might know him. Yes, everyone else is from Bath. There is 2 anthropologists, which I'm very happy that I've worked with them. I've learned a lot from them. Dr. Natalia and Jason Hart. Both of them I've learned a lot. One of the very good points of working with the humanitarian sector is that you always get the opportunity of learning different disciplines and learning from people from very different educational backgrounds. So work package 1 in the project was completed some of the largest uniform thermal and air quality in social studies in several camps around the world. Then all the data was fit into computer models, and then mathematical model and computer models were constructed, and then based on the feedback from those models, from those computer models, real life large scale prototypes were constructed and also were tested, some of them at the BRP in Swindon, British Research Park. The photo that you see with the air conditions is actually a climate control chamber. You can prototype your design and then test it from -20 degrees to +40 degrees. We used these climate chambers. We built 12 shelters in Zatari and Azraq refugee camps, and we investigated using several data collection methodology. The WP4 conducted design assessment workshops, participatory design workshops, and trying to get the feedback. So it comes back to inclusive design, trying to include the beneficiaries from the design stage before we go any further. The photo on the very right top won the RedR Architecture Award, RedR Gold Bronze Award for in a photo competition. That's a lady who is designing her house using artificial intelligence and virtual environment. So that was cool. In work package 5, we investigated the material flow and knowledge flow in the displacement when the shelters are built by the beneficiaries themselves, or if they are assisted by the aid agencies. Where do they get the material from? Where do they get the information on building the design, and where do they get the designs? So we use social network analysis to investigate the material flow, and we use SNA as a tool of visualization. So the graphs on the right that you see, these graphs have no geographical information. They do not have any GPS coordination. They only have information as words. There's no numbers, but they still shape the way that actually those camps or those villages are located. The top right is from Bangladesh. All the camps is located, the whole camp is located in one location, and that we have this big lamp. The top is from Afghanistan, 4 different villages, and they are creating this 4 colors. So we investigated SNA if this could be used to visualization of the material networks, and this can help the humanitarian agencies with developing their strategies of response. So if you are a mathematician, you can still play a role in the humanitarian sector, and a very vital one. So I would like to ask, and please add your comment, your answer in the comment box. What do you think this is? And I will answer it in later. Just not to let you, I hope you're still awake and it's not too boring for you. So just have a look at and tell me what this is. This is what does it look like to you? Just your ideas, and I will answer later. You had a look? Good. Move. Okay. I hope you have seen it. Okay. So why did I do this research? Why did I investigate the role of computational tools in designing healthy housing for the displaced? Millions of people are displaced. 2 million now. That is more than the entire population of the UK. 1 in every 110 seconds is forced to flee. That is almost doubled now with the Afghanistan influx of refugees. The cause of displacement is divided in the literature into natural disaster and man-made disaster, but actually for me, both man-made disasters, or it's all the consequences of all actions. If the wildfire occurs, if the floods occur, the flash flood occurs, or probably the earthquakes, which we don't know yet. So once people are displaced, they're categorized into 4: refugees, IDPs, asylum seeker, and state level. Refugees are those who cross international borders. The IDPs are those who cross international borders, but they are displaced from their own locations, and they are in similar situation like refugees in most cases. Asylum seekers are, the difference between an asylum seeker and a refugee is just administrative. So by the time it's decided that you are granted refugee status, you remain an asylum seeker. I was an asylum seeker for 1 year in the UK until I was granted refugee status. Stateless are those who do not have currently a government, and this is very political, and I will not go into this. So there are very large-scale camps, some of them turning into mega cities now, and they have been there for a very, very long time. So these are not temporary solution, and we really need to look at this and try to solve this. Imagine these camps being dismantled, and once the refugees or the displaced left, the amount of environmental impact that these shelters would have, the amount of trees that are cut, the amount of damage that is done to the land. This is huge. This is why we need to have inclusive policies at the government level, and also have inclusive design and approach from the very beginning. We need to be open. Displacement is going to occur, either we like it or not, either because of conflict or the natural disasters. So camps in Pakistan have been running for the past 30 years. I've lived 1/4 of my life in one of the camps, which is called Kabapian in Peshawar, in the outskirts of Peshawar city. Kotapolong, Dabab for almost 30 years. Atari and Azraq refugee camps are now for 9 years. So we can't look at them as temporary solution. We need to find long-term solution. And this is why engineers are needed. And then shelters, the whole terminology is very confusing. And that's why probably it led to not being studied for so long. Shelter, when I was telling people in the UK that I'm investigating shelter, the immediate image in their brain, in their mind would be shelter for a bus stop or something at the backyard, a shade house. Shelters are actually houses. This is where people live for 30 years, 20 years, and there are resources that say the average life of a refugee living in the camp has now reached 17 years or in displacement. So 17 years is a lot. These shelters currently, they are very cold in winter, very hot in summer, and the U value for a tent which is distributed is 40 times more than a cavity wall. The V value is the ability to transfer heat, the heat exchange. They are culturally insensitive. They do not provide privacy for the people who are living in these shelters. There's no space for hospitality, and they're not flexible. They're not flexible. You can't adapt them to your choice or your selection, even though we have so much knowledge. I mean, for example, if we take construction industry, we have advanced so much, and we have so many things to learn from the standard engineering and the building science or the construction industry, and we can implement it in the humanitarian sector. All right, good. So I came and I said, I am going to design the perfect design. Considering all these problems, I said, all right, I'm going to design a shelter that is acceptable everywhere, that is thermally comfortable, that has partitions that provide hospitality, and it's acceptable everywhere, and it will have no political challenges anywhere. It can be implementable, deployable anywhere. And I was very wrong. So I started doing research. So before designing, I have to do a research on what is the current practice, what tools are used, because in construction industry, we use simulation tools, we use softwares before we construct. There's a whole pre-construction stage that a design goes through. Then it's given a go or no go, or a green light or a red light. So I started searching everywhere, and I particularly started searching for design tools. And I went to refugee camps, I spoke with the professionals in the field, I spoke to practitioners, designers, I conducted focus group discussions, surveys, and I conducted design exercises. And I found that they're not using any simulation software. So, for example, the survey that I conducted with participants from the humanitarian sector who are working in the field, I tried to look into the themes of that are important in a design. It's lighting, cultural compromises, ventilation, thermal aspects, and energy efficiency, and the environmental impact. What tools do you use when you are designing the shelters, and how do you assess them? How do you rate their performance? One of the experience that I learned, one of the lessons that I learned is whenever you are surveying humanitarian sector, give it 3 times more than if you are investigating something in the standard construction industry. They are very busy, I think. So I found that except Excel and AutoCAD, no other simulation software, any other performance simulation software is used. And why not used? It's because they are very expensive, they're very complex to use, and they require a lot of information that's most of the time in the field aid workers do not have. The lack of time, resources, and information, and the required skills were noted as the reasons for not using standard simulation software packages. So there was need to design and construct tailored design assessment platform or tools that is open source, that is free to use, and that is non-specialist, requires minimal skills to run. So before constructing the tools, I went to the field, collected lots of data because there was no data, there was no measured data about these shelters. I went to Ethiopia, Djibouti, Turkey, Jordan, and we collected remotely data from Afghanistan. The photos you see are from Djibouti only. These were the devices used. Eye buttons are sensors that are used inside the houses or inside the premises or shelters to collect temperature data. Heat stress is also a similar thing, but it's handheld and you can take it with you while you're conducting thermal comfort surveys or winter thermal comfort surveys. They're all aligned, 8 of them, because I wanted to check which one is more precise, so I can take that one with me. So there comes the software and also the mechanical engineering. These were other devices. Dust track is used to look into air quality. Also the tubes, forgot the names. They are used to look into the particles in the air. Then I reached to a point that, it's actually not about the design. I was thinking the same as others were thinking in the industry or in the sector. The humanitarian sector was overwhelmed with the number of designs that they are proposed, but no design tools. So I started thinking, okay, there's need to administer or inject engineering, the science of buildings, into the process. So if you refine the process, the product is going to be refined automatically. This is why we started constructing easy to use tools for different and very important aspects of the refugee house design or shelter design. 4 tools are available on the websites. I will provide you the link. One of them is the environmental impact calculation, the thermal model, thermal calculation, the structural stability calculation, and also daylighting. So how do you integrate the sciences? You provide these tools to the humanitarian aid workers. They will use it and they will integrate the science into the design process. So one of the what we did is integrate all of the tools into one platform that we call SAM. So it's called Shelter Assessment Matrix. With the unique part of SAM is that the needs of the displaced is integrated as the input in the tool. So you unconsciously or subconsciously, as you are doing the design assessment performance, you are taking into account the needs of the displaced in the whole process. And it brings multiple disciplines into one platform: the social cultural aspects, the political aspects, the engineering, and then supply. These are the output. This is the output of the environmental impact assessment tool, which we call EE and EC. And not only it calculates for you the amount of embodied energy and embodied carbon, but it also tells you where do you stand among the 81 designs that we have studied. We have studied 81 designs around the world. And if you assess your design, the red line will tell you how good or bad is your design. So again, a decision support tool. Should you construct this design here or not? The second is a very beautiful tool, ShelTherm. It's a universal thermal model for shelters. You can assess any shelter design model, and it has a material palette inside it, 1,200 combination of material and 3,000 locations, weather files for 3,000 locations is embedded in this tool with 1,200 combination of materials. So you can choose different types of material and window location, cross ventilation, single ventilation, roof, floor, all these by just click of buttons. You just need to click radio buttons and it will tell you how good or bad will the design perform in the worst days in the whole year. So in the summer, the hottest day, in the winter, in the coldest day. And it will tell you if actually the design is making the situation better or worse for the refugees or the IDPs. The tool on the left is a simple spreadsheet that you need to provide 3-4 inputs, and it will tell you the daylight inside the shelter. And the tool on the right will help you to calculate the structural stability. This is based on the formulas provided by Arab. So it's a tool that enables you to understand how much pull resistance will be needed from the foundations of a shelter, particularly in places like Bangladesh, where typhoon occurs and lightweight structure is constructed, so it can be blown away by typhoons very easily. So the SAM is basically has 9 design criteria and then 34 key design issues. These 9 design criteria, 34 key design issues are backed with tools that I show you, 4 of them, and also 2-page guidance notes. So if you do not want to use, there is 2-page guidance notes that will inform you about certain design or key issue. For example, if you do not know about the air quality inside shelters, there will be a 2-page document, the cream of the whole package, that you will read, and it will tell you what consequences can it have if the displaced are given stoves that are run by kerosene. I will now play a video. How long do I have? Okay, I want you to look at it. I hope you can hear it. This will
Millions of people are forcibly displaced around the world and are encamped in temporary shelters, often for more than a decade. Unfortunately, many of these shelters provide poor conditions in which to live and raise a family. Some of the problems are physical. For example, temperatures above 40 degrees centigrade in shelters in summer and below freezing in winter, or dangerous air quality from cooking on open fires with no chimney, or insects attacking the structure. Some are cultural, such as the use of low-level windows allowing men to see into female areas, or the lack of separate male and female entrances. Others security-based, for example the use of materials that are not knife resistant. The Healthy Housing for the Displaced project led by Bath University has studied the conditions provided by shelters around the world and asked the displaced how their accommodation might be improved. The results have been enlightening. The constraints of cost, time and materials make creating ideal living difficult, but we have found that by applying some basic building science and attending to the local culture, lives can be transformed. By discussing the problem with our aid agency and architectural partners, it became clear that much of the issue was due to there being no structured processes for developing shelter designs that considered these physical and societal concerns. The guidance that existed was scattered, and lessons learnt were often lost before the next project. However, we also discovered that agency staff and architects would welcome a process if it were supported by the tools needed to analyse the situation and any proposed design. In response, we designed the Shelter Assessment Matrix, or SAM. SAM is a simple spreadsheet supported by a series of computer tools that predict the performance of a shelter. For example, the likely temperature within the shelter in winter and summer in a specific location. SAM also contains a set of short information sheets that discuss the various issues for those new to shelter design on topics such as ventilation, cost and security. SAM can be used by aid workers, designers or architects to 1. Inform design, 2. Upskill staff, 3. Help write tender documents, 4. Score tender responses, 5. Identify issues, and 6. Improve designs. SAM operates using 34 key issues that our research has shown to be critical. A central discovery by the team is just how important location and climate is, and just how much of a difference it makes to speak to the occupants, or those from a similar setting or group before designing. This might seem obvious, however our work has shown that architects can have a tendency to think that it is possible to design a shelter that will work in the majority of settings without fully considering the impact of climate, or that different displacement settings have very different budgets, or that the displaced are not an homogeneous group, or that certain materials might not be allowed in some settings. In addition, aid workers can sometimes overly rely on knowledge from previous projects in very different settings. Key to SAM is that it first asks the user to think about the requirements, i.e. the setting, the occupants, the costs, and the thoughts of the host government, etc., then to input the details of the shelter. The shelter is then scored against the requirements, so it is the match between the setting or context and the shelter that is analysed. As each of the 34 issues is considered separately, the user can quickly identify weaknesses or potential improvements. SAM can be downloaded from our website www.hhftd.net and is free. We hope you find it useful.
Yes, so that was about SAM, and I'll move forward. So this is how SAM is, the output of SAM is. It's giving you, it's a decision support tool. These are the 9 designs that I have evaluated, 9 existing shelter designs that I used SAM and evaluated them. So you can, it can immediately give you an image, like the top left one is very good at pre-construction, but it's weak in others. For example, the top bottom one, the top right bottom one is very good in terms of safety. It's performing very good in terms of safety, but it's not performing very good in terms of pre-construction, well-being and adaptability. So it's difficult to construct it actually, but it provides good safety. So then you as an aid worker have the knowledge, the information to choose or change a design, or you can, it also presents the output as such that there's this traffic light system that tells you where the problem is, so you can work on that problem and solve it in that, or modify the design so it's more acceptable to that particular. So it enables contextualized design performance assessment. So when I ask what is this, actually this is a simplified LAMP parametric RC network model, and the reason that I chose this one is because we constructed this in the very first year for my PhD with Farhad Mofidi, who is, I don't know where he is now. So you can use your electrical engineering knowledge in the humanitarian sector. So when I was presenting for a group of students, they never thought that the knowledge that they gained in the very first years of their degree will play a significant role in changing lives. So whatever this discipline you're doing, like RC networks, it's more electric, but we used it as a thermal model, and you can use this to calculate the heat exchange in a building, in a shelter. So I will see who had got the right answers later. So that is the model. This is how it looks, and this is what it produces. So this is the same shelter design, but changes. The parameters are changed. You have seen the parameters on infiltration, ventilation, resistance, and thermal mass. So in the one which we added thermal mass and we added ventilation, the indoor temperature immediately dropped down to 5 degrees. So it's predicting correctly. So you can use whatever skills you have. There's always an opportunity in the humanitarian sector. I have written 7 research articles, co-authored 7 research articles. 4 of them are published, 2 accepted, and 1 is submitted. The first one looked into the role of computational and IT tools in disaster relief shelters. The second one, we investigated the environmental impact of shelters around the world, and we published a tool for that. The third one is about the air quality. We went to so many refugee camps, investigated the air quality in shelters, and we submitted that paper. It's available online. The fourth one, we used social network analysis to investigate material and knowledge flow in the disaster and the post-disaster reconstruction. The fourth one is about the structural stability of shelters. We have published that tool, which is based on the formulas provided by Arup. The sixth one is the thermal model, which is we call ShellTherm. It's an it's a thermal model provided for non-specialists, and you can evaluate the thermal performance of any design and given in one of those 3,000 locations. And even if the material palette does not include there, you can still provide your U values, and it will calculate for you the indoor temperature, and it will tell you if the shelter is performing good or bad. The last one is the SAM. I tested SAM as a pedagogical tool platform. So we used it with 72 aid workers to test if it will be used to uplift the knowledge of users. And we found out that in pre-use and post-use, so we did a test before they used SAM, and we did a test after they used SAM, and they were given the time to read through the contents, the guidance notes, the tools, and then we did another test. There was 14% uplift in their knowledge regarding key design issues of a refugee house. I'd like to finish that those who understand the disaster management or disaster, they might not have the skills of engineering, and those who has the skills of engineering might not know how to manage a disaster, how to respond. So we both have we have the chance to learn from each other, and developing non-specialist tools. I would love to see a tool developed by a social scientist or engineers, for engineers to use in the in the future. I mean, you as those who are displaced, they have lost everything, every single thing they had, and the only thing they have is hope. And you as a humanitarian engineer can be that hope, and you can bring a smile in their faces. Thank you.
Thank you. No, this was really fascinating. We have a few questions in the chat box. So if we only have like a few more minutes left, but if you could answer those questions, and I don't know if anybody else would like to ask you a question. As I said, we don't have much time left. So I don't know if you can see the questions. No. So the first question from Brian Reed: what existing decision support tools did you review? Not just in shelter, but other sectors too. Which existing ones seem to work, are not used?
Well, I reviewed the standard simulation softwares in the construction industry, IES, Design Builder, Bluebeam, all these very sophisticated softwares. Then I went into the humanitarian sector. There are many guidelines. They are narrative, 500 pages, 300 pages. And in a disaster scenario, you do not have the time to read all of these, and you can't actually memorize all of these. So you need robust tools. You need tools that has the science inside it, but they're robust, they're quick, and they can help you to decide. For example, you are an aid worker. you've got 9 designs, 10 designs, but you do not know which one to choose. So this provides you with an evidence-based approach, with an evidence-based decision support tool. The tools I've looked into SPARE, I have looked into the shelter design guidelines, I have looked into the transitional guidelines, you name it, and I've looked at all these design guidelines, and we have picked all the things from there and combined it with the science, combined it with social science and feedback and inputs and requirements from the displaced, and blend them all into one platform to enable a multidisciplinary design approach.
There is also a question from Ulysses. Also, can you advise on the best method to get into international development work, particularly in the WASH sector? I'm an experienced engineer and willing to work in the sector, but had difficulties as I do not have any previous experience. For that, I can probably answer this question. So we offer a range of different training courses. One of them is, so you want to be an aid worker. I think the next one, I'm not really sure, but it's on our website. So that's probably the first step that can kind of help you in kind of like, you know, giving you directions where to go from here. And I think we have time for one more question. Brian, the importance of consulting users has been around for decades, but seems to be frequently forgotten. How can we ensure that this is prioritized in engineering in the future?
The importance of what? Sorry, I've missed the first bit.
The importance of consulting users.
Well, every agency you talk to is for emphasizing on inclusive approaches. It used to be said more, but now it's done more. So hopefully we are going in the right direction. And the reason that we talked and we investigated so much, we spent so much time into getting the feedback, the inputs from the users is an evidence that, and we also would like, I want to advocate everywhere, wherever I go, I try to advocate. And that's what the humanitarian agencies are doing, actually, including people from the very initial stage of the design. But how should we would we do it? That is a bigger question, I think. Barry has asked that, what is your role? I work as a technical coordinator in RedR. I am the focal point for the third edition of the Engineering in Emergencies. This book will be published, a very good book. Hopefully it will be open source, and it's a very good book actually for those who want to work in the humanitarian sector.
Thank you, Noor. I think we probably have to leave it here. Once again, just to remind you that these webinars are free for anyone to attend, but they are, however, a part of our Wear Red campaign. So we're hoping to raise funds to help us continue our very important work. So the easiest way to donate is by clicking on the Just Giving page. However small or a large donation you can make, anything that you can afford. And we're going to be running the webinars until the end of the week. So there's still a lot of interesting content to come. So just to give you a heads up, tomorrow's session will be about how we can make more sustainable choices in our daily lives. So a very interesting and a very relevant session. So thank you once for joining us. Thank you, Noor, for a really, really interesting presentation, and have a lovely rest of the day.
Thank you. Thank you, everyone who participated. Please do contact. I will try to, I don't know how to share the presentation, but we will try to put it on the website somewhere, and Aoife will help me with that. And I forgot to thank Anna, who helped me with preparing the video. So thank you so much. Thank you, everyone.
Thank you.
Bye.
Thank you very much. Bye-bye.